This right here is a little pendulum simulation that I created on the Khan Academy computer science section or on our code scratchpad. And the purpose of it is for it to really be a virtual laboratory for you to kind of get an intuition for what affects the pendulum, how does a pendulum change depending on different parameters. So right now it's just motionless, but we can, if I click on it, I can change the length of the string or I can change the initial angle. And you see that they're changing in the top left corner. So right now my initial angle is 30 degrees and my string length is 8.5 meters. The mass of what you see, that little bunny looking thing with the on the spaceship, we're assuming 10 kilograms, and the gravitational field is the strength of the gravitational field is 9.8 meters per second squared, which is roughly what it is at the surface of Earth. And so when I let go of the pendulum, so I just unclicked right there, you see the pendulum swinging back and forth. And the current implementation of it assumes that there's no air. So there's no air resistance or no energy loss to the friction with the air, or even with the friction of the pendulum itself where it pivots or anything like that. So one thing I encourage you to do at first is just play with the pendulum and get a feel for how it moves. See what happens when maybe you have a shorter string. See what happens when you have a longer string, when you have a bigger angle or a smaller angle. But that's not the only thing that you can change. You can also change the mass of the object. So you see one, it gets a little bit bigger, but also you see this mass number changing based on where you move this little magenta-haired individual. And you can also change the gravitational field to see how would this pendulum operate if it were on a different planet maybe. And so if we change this, we click on the star, this little small star, we can change the strength of the actual gravitational field. So the first thing that I think is interesting is just to play around with this a lot and get a sense for the pendulum. And then I want you to start thinking about how these different things, the gravitational field, the length of the string, the mass, the initial angle, how this affects the period of the pendulum. And just to be clear what a period of a pendulum is, it's how long does it take for the pendulum to go from one spot or one state to that same state again. So here, from there, let's say you start there. So from that moment all the way back to this moment, how much time has passed. And you see here that the tool actually measures it for you. It was about 5.1 or 5.2 seconds. And it's very important, it's from the exact same state. So if you want to measure it from the bottom, you have to measure when it's going in the same direction. So it could be from now, not until now, but until now, when it was going backwards again. And so it's going to take it a little while. We changed the initial angle a little bit, and so we got a slightly different period. This predicted 0 seconds, that is wrong. And that's wrong because the whole point of this is for you to explore how can you predict what the period is based on things like the initial angle, based on the string length, based on the mass. So one thing I want you to do is just play with this as much as you can, change the mass, change the gravitational field, and try to get a sense. And you might want to do one at a time. So for example, you might only want to change the string length first and say, well, if I have the same initial angle, let's say I always have a 20-degree angle, and I change the string length, how does that change the period? And then hold everything constant and see how the gravity changes it. And you might want to even plot it on paper and see if you can get a sense of what the mathematical relationship might be. And once you get a really good sense of that and you really want to take it to the next level, and you can even play with mass, see how that might affect the period. And once you do all of that and you start to have a pretty good intuition of things, the next step is to try to come up with a formula, try to implement this predicted period function. And if you want to go in the code, it's right over here. So this is what I did not implement. You see I just set p equals 0. That's why it just says 0 seconds right over there. But you might want to set up some code or put up some formulas or do some computation here to better predict the actual period. And I encourage you to do any research you might have to do research on the web. Try to implement things that you find there and see how good they actually do approximate the actual period. And it would be fun to see if you can get even more accurate than anything that you even find on the web, any of those formulas or anything like that. But the key thing is to really try to understand in that first step why any of these formulas actually make intuitive sense, why they actually feel or why they might look the way they do. And if you want to really understand all the code, or maybe even try to kind of branch off and do a save as and make your own version of this code, I encourage you to press play right over here. That's an explanation where I'm actually explaining the actual code. And from there, you can take this wherever you want. You could add more bells and whistles to this simulation, or you could even turn this into some type of a game.